So if I'm given the second derivative, first I have to find the first derivative and then the function. So it's a two-step solution. 2 stays by itself. Which function prime is x?
X squared over 2.
Very good. Awesome. Plus 3. Which function prime is e to the x? E to the x plus a constant c. And now we are looking at f of x. 2 over 2. Which function prime is x squared?
X cubed over 3.
Brilliant. Good. Plus, the same thing. Plus, which function prime is c?
Cx.
Very good. Plus a constant d. And this is it. This is the family of functions with this second derivative. Okay. 52, and then we move on to another type. We are given the second derivative as the cube root of t minus cosine t. And look what they're telling us. F of 0 is 2, and f of 1 is also 2. Initial conditions. So this problem is very similar to this, right? Here I was not given these conditions. So obviously I will end up with a C and a D. So what do you think are these for? What will they do?
Help us find C and D.
Exactly. So at this point, we will now, so this is the most general antiderivative, a family of functions. But this will give a unique, or if you want, only one function with the given conditions. The second derivative is this, f of 0 is this, f of 1 is this. It's not going to be the most general antiderivative. It will be a unique, just one particular function that fulfills the given conditions. That's why this is given to us. Awesome. So let's start. So let's find the first derivative. And yes, I will change this into t to 1/3 minus cosine t. So then, what function prime is t to 1/3?
Would it be T to 4/3?
Yes.
Over 4/3?
T to 4/3 over 4/3. Excellent. So it's 1/3 plus 1. Very good. So minus, which function prime is cosine t?
Sine t.
Excellent. Plus a constant c. I stop and look at the conditions. Am I given a condition for f prime? No. So I have to continue. If I were given a condition for f prime, I would have found c immediately, but I can't. I don't have any information about f prime. I'm not given a point for f prime. I am given 2 points for f, 0, 2, 1, 2. But I'm not given anything, any information about f prime. So I have to continue. So I'll flip this. So I have 3 over 4 t to 4/3 minus sine t plus a constant c. Now, if you don't like c and d, you can write this as c1 and this as c2. That's fine too. It doesn't matter. Good, so let's find now the function. 3/4 will stay. And now, which function prime is t to 4/3? So I have to add 1 to this, and I get 7/3. T to 7/3 over 7/3. And now careful, which function prime is negative sine t?
Positive cosine t.
Very good. Plus, which function prime is c?
Yeah.
ct. Very good. Yeah, X up. Plus d. Sorry, you're right. I wrote x. So I flip this. So I have 9 over 28 t to 7/3 plus cosine t plus c. No, I didn't mean that. ct and plus d. Now we go back to our given conditions, initial conditions. And we have f of 0 is 2. So f of 0, 0, 0, but 1. So 1 plus d equals 2. Because this is 0, but cosine 0 is 1. 1 plus d must equal 2. So then how much is d?
One.
Good. So I will plug it in. So f of t for now is 9 over 28 t to 7/3 plus cosine t plus ct plus 1. I also have another condition. F of 1 is 2. Meaning, for this function, right, remember, 1 means 1 radian. It's not 1 degree. I can't have in a function put 1 in here and degrees here, and you know this is very important. So f of 1 is 2. So this is 1, so 9 over 28 plus. This is cosine 1 radian. No one knows what that is, and we don't really know. We don't really care. Plus c plus 1 equals 2. So c will be 2 minus 9 over 28 minus cosine 1 and minus 1. Everything moves to the other side. So let's get c. 2 minus 1 is 1, minus 9 over 28, and minus cosine 1 radian. 1 radian is about 57 degrees, but we want an exact number, so we don't have that. So 28 minus 9, so then c equals 19 over 28 minus cosine 1. Finally, the function f of t equals 9 over 28 t to 7/3 plus cosine t plus c t plus 1. And this is 19 over 28 minus cosine 1. So far, so good? Any questions here? Anyone? I'd like to look at one more. like 67.363. A of t. What derivative is A of t?
The third.
The second. Good.
Oh, sorry.
So they're asking us, find a particle is moving with a given data. Find the position of the particle. So we're given the second derivative. We have to find the velocity first. Can anyone give us the velocity?
I guess it's a t
Square.
squared over 2, so
Very good. Let's write it until we get used to it. That's fine. Plus, which function prime is 1?
t.
Very good. Plus a constant c. And now I'll simplify. It's not a big deal. We are told this time v at 0 is -2. So again, v of t is t squared plus t plus c. V of 0, 0, 0, plus c equals -2. So then I know that the velocity function is a unique function, t squared plus t minus 2. So we determine the velocity. And now we want to find the distance, the position formula. So can anyone give us the distance?
T cubed
Very good.
over 3
Excellent. Plus
plus t squared
over 2. Very good. Minus.
minus 2t.
Very good. Plus a constant d. We are given a piece of information that s of 0 is 3. 0, 0, 0 plus d must equal 3. So d equals 3. So we found the distance formula, t to the third over 3 plus t squared over 2 minus 2t and plus 3. Guaranteed a unique function. Unique function that has this second derivative. Its first derivative at 0 is -2, and the function value at 0 is 3. Guaranteed. It fulfills those conditions. Any questions? Do you think that this is clear? The anti-differentiation and the simple applications we looked at? Do you think we need more? Okay, we'll have many more chances to do more. Okay. Chapter 5. Chapter 5 has 5 sections. So there is a lot of prep. It's entitled Integrals. There's a lot of work before I even mention that word again. Okay, first of all, we're going to talk about something called the summation or sigma, summation notation or sigma notation. Okay, so S signifies sum. We do not use this letter. We use a Greek letter that signifies the same thing. And this is called sigma. So why do we use this and not this? Why? Because it's fancier? No. It's because it serves a certain purpose. the summation notation has to start somewhere. You can start it at 4. You can start it at 1. You can start at 0. But it has to start somewhere. So this is the starting point. It's called the lower limit. I don't really like to use the two words lower limit because you may think at LIM. No, no, no. This is the first entry, if you want, or the first or the original. It is called the lower limit, to be exact. But it has nothing to do with LIM when such and such. Okay, so the lower limit is 4, and it has to have an upper limit. It can be 100. It can be n. It can even be infinity. However, it has to have an index. What is the index? This is the index. The index is normally I, J, or K. Can you use A? Good luck. Same thing. There is no problem. So, and something has to follow here. So let's say AI. This is a generic term. What does this mean? It means when I is 4, I have A sub 4. The sum says plus. When I is 5, I have A sub 5. The sum says plus. When I is 6, I have A sub 6 plus, and exactly 3 dots, not less, not more. When I is 100, I have A sub 100. Instead of writing this, we write this kind of fancy notation, and we read it in the following way. The sum, as I goes from 4 to 100, from A sub I, instead of this. Okay, so then we know that this is the upper limit. Nothing to do with the LIM. Is the end of the index. The index starts at 4 and ends at 100. Lower limit, upper limit. From this generic term, whatever that represents. And here's another example for you. So let's say I have the sum from I equals 1 to 10 from I squared plus 3I plus 2. What is all this? Okay, when I is 1, I have 1 plus 3 plus 2 plus. When I is 2, I have 4 plus 6 plus 2 plus. When I is 3, I have 9 plus 9 plus 2 plus 3 dots. Plus, when I is 10, I have 100 plus 30 plus 2. And yes, I can determine these. I just have to be patient or share my screen and go to the sum. Of course, make sure you get out of there. Okay? So let me look right here. Summation, sigma. So press 0. The lower limit, we have to use x in the calculator. So we have x from x equals 1, and the upper limit is 10 in my little example here, and in parentheses, x squared plus 3x and plus 2. Very beautiful here, 570. Okay, so now let's also illustrate